another problem up here where, again, the angle involved here is not just x. In this case, it's 3x. But if I take a look, there's one angle, it's 3x, and there's just one trig function, it's secant. So I shouldn't need to use any identities to rewrite this. I want to just solve this. So I'm going to solve this by finding 3x in the interval from 0 to 2 pi. Then I'll get all 3x. Once I have all of those, I can divide by 3 to get all values of x, and then I can get x in the interval from 0 to 2 pi. And I probably should have said from the beginning, these two parts right here, that's what the question is asking for. Find all solutions in this interval and find all solutions to this equation. Okay, now this is quadratic because we've got our secant squared. There are actually two different ways I want to show you that I can deal with this to get it down to just a secant. Okay. One is that I could actually factor this. Okay. This is a difference of 2 squares. That's secant squared. 4 happens to be 2 squared. So I could factor this as secant of 3x plus 2 times secant of 3x minus 2 equals 0. Okay. When I have the same two parts, secant of 3x and 2, but they're connected with opposite signs, if I were to FOIL this out, the first terms would give me my secant squared 3x. The outsides and insides would be exact opposites, so they would cancel, and then the last terms would give me the minus 4. So now, if two things multiply to give me 0, because notice it was set equal to 0 to begin with, then either secant of 3x plus 2 equals 0, or secant of 3x minus 2 is equal to 0. Okay. Here, this would mean that secant of 3x is equal to negative 2, and here this would mean that secant of 3x is equal to positive 2. Okay, I'm going to just show you another way that I could get there, because this just involves the secant squared and a number. So my other option would be to say secant squared of 3x is equal to 4. I could move that 4 over to the other side. And then I could take the square root of both sides. So the square root of secant squared 3x equals the square root of 4. I just need to remember that that's the absolute value of secant 3x. That would equal 2, so that secant of 3x would be plus or minus 2. And I get to the same two options that I got to by factoring. Okay. So when you are solving by taking square roots like this, we need to remember that I don't know whether secant of 3x is positive or negative. Okay. But I do know that the square root function can only spit out non-negative things. So I'm getting the absolute value of secant 3x, which is plus or minus that. Sometimes people will go straight from here to here. Basically, if you're solving an equation by taking the square root of both sides, and you did not know whether your variable expression was positive or negative, you want to think of it as just, I'm taking plus or minus the square root. Okay. All right, so however we got there, we get to these two equations. Now, if secant of 3x is negative 2, I don't carry around a whole lot of values of secant in my head. So to recognize whether this is one that I know or whether I'm going to need to use inverse trig, I would just rewrite this as 1 over cosine of 3x equals negative 2. And that's going to mean that cosine of 3x is negative 1/2. I can actually just take the reciprocal of both sides. Okay. Same thing here. This is 1 over cosine of 3x is equal to 2. That means cosine of 3x is the reciprocal of 2, which would be 1/2. And now that I recognize as a value that I see fairly often. Now, what I can do is I can actually solve, whoops, I want to draw this a little smaller. I can solve both of these at once. Because basically, I'm just going to have a solution in all 4 quadrants. So I'm going to have a 3x here. I'm going to have a 3x here. For this 3x, cosine of 3x will be positive 1/2. For the 3x in quadrant 2, it's going to be a solution to cosine 3x equals negative 1/2. In quadrant 3, cosine of 3x will be negative 1/2. And I'll have a solution in quadrant 4 where cosine of 3x will be 1/2. Okay. So basically, because I get both signs but with the same absolute value, all of these are going to have the same reference angle. And that reference angle will just be what this solution is right here. This is saying that 3x is the acute angle whose cosine is 1/2. So if I draw my 30, 60, 90, 1, 2, root 3, we're talking about 60 degrees. So 3x would be 60 degrees, which in radians is pi over 3. Okay. So here we get 3x is equal to pi minus pi over 3. That's 3 pi over 3 minus pi over 3, so that's 2 pi over 3. Here we get 3x is equal to pi plus pi over 3. That's 3 pi over 3 plus pi over 3, so that's 4 pi over 3. And here we get 3x is equal to 2 pi minus pi over 3. So that's 6 pi over 3 minus pi over 3. So that's 5 pi over 3. Okay, so we have 4 values that 3x can be in this interval from 0 to 2 pi. So it could be pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3. Okay. Then for 3x, what I'm going to do is I'm going to actually just write out the equations that say that 3x is one of these 4 things plus 2 pi n. Because I'm going to use those equations, I'm going to divide by 3 to solve for x. So I could have 3x is equal to pi over 3 plus 2 pi n. I could have 3x is equal to 2 pi over 3 plus 2 pi n. I could have 3x is equal to 4 pi over 3 plus 2 pi n. Or I could have 3x is equal to 5 pi over 3 plus 2 pi n. And for all of these, of course, n is an integer. Okay. So these are my solutions for all values of 3x, but that's not part of my final answer. My final answer is what x can be. So I'm going to solve for x by dividing by 3. Dividing by 3 means multiplying by a third. So if I have a piece that's a fraction, I'll multiply that by a third to divide by 3. When I have a piece that's not a fraction, I will just divide by 3. So I'm getting x is equal to pi over 9 plus 2 pi n over 3. Here, if I do the same thing, again, multiplying by a third when I already have a fraction, writing it as division when I didn't. So I'm getting x is equal to 2 pi over 9 plus 2 pi n over 3. Here, dividing by 3, I'm going to get x is 4 pi over 9 plus 2 pi n over 3. And here, dividing by 3, I'm getting x is 5 pi over 9 plus 2 pi n over 3. Okay. So for all values of x, I've got these 4 expressions, all of them with n equal n an element of z. I'm going to just copy them into an answer box here, just so it's all together. So we had pi over 9, yes, plus 2 pi n over 3. We had 2 pi over 9 plus 2 pi n over 3. We had 4 pi over 9 plus 2 pi n over 3. And we had 5 pi over 9 plus 2 pi n over 3, where n is an integer. That would be my answer for all values of x. Okay. Now, I want to get the x values between 0 and 2 pi. Take a minute, see if you can figure out how many x values you think we're going to get. Pause the video if you need to. We're actually going to get 12 because we had 4 values of 3x between 0 and 2 pi. But because we were working with secant of 3x, which goes 3 times as fast, so it covers the distance in a third of the amount of time, we're going to get 3 periods of that function in this interval. So we're going to get 3 times as many solutions. Okay. So I'm going to just list n and x, and I'm going to just sort of label these guys, A, B, C, and D, just so we can sort of follow. So working with A, if n is 0, I'm going to get pi over 9. Okay. If n is 1, I'm getting pi over 9 plus 2 pi over 3. Now, I'm going to just note that that's pi over 9 plus 6 pi over 9, so that would be 7 pi over 9. Okay. So if I'm adding 2 pi over 3, every time I do that, I'm adding 6 pi over 9. That's going to be important because I'm always adding to ninths. And let's just notice that 2 pi would be 18 pi over 9. So if I go bigger than 18 pi over 9, I'm too big, but that's my cutoff. So if n is 2, I'm adding pi over 9 plus 2 copies of 6 pi over 9, because that's what 2 pi over 3 is. So that would be plus 12 pi over 9. So that would give me 13 pi over 9. Oops. 13 pi over 9. Now, if I were to add another 6 pi over 9, notice that's going to take me to 19 pi over 9. That's too big. That's what I expected. I expected for every one solution here to get 3 solutions here because of that 3. Okay. So these are the 3 solutions that I get from A, from B. If n is 0, I'm just getting 2 pi over 9. If n is 1, I'm getting 2 pi over 9 plus 6 pi over 9. Notice, once I recognize that that's what I'm adding, it starts to go a little faster. 2 pi over 9 plus 6 pi over 9 would be 8 pi over 9. If n is 2, I'm adding another 6 pi over 9 to that, so that would give me 14 pi over 9. And if I added another 6 pi over 9, that would be too big. Okay. So, n and x. The table's not absolutely necessary, it just helps me keep track of where things are coming from. So, with C, if n is 0, I'm expecting to get an answer for n equals 0, 1, and 2. So if n is 0, we're at 4 pi over 9. If n is 1, I'm adding 1 copy of 6 pi over 9 to that, so that's 10 pi over 9. If I add another 6 pi over 9, that's 16 pi over 9. If I were to go one more time, I'd be bigger than 18 pi over 9. From D, we've got, if n is 0, 1, and 2, okay, I get 5 pi over 9. Plus 6 pi over 9 would be 11 pi over 9. Plus 6 pi over 9 would be 17 pi over 9. So my answers for x would be all of these 12 things. And probably what I would do so that I don't have to recopy them is I would just put a box around them and say, those 2 purple boxes are my answers to this question. Those are all of the values of x between 0 and 2 pi.